C# provides three different structures we can use to create loops: while, do while, and for. They each have their own purpose, and you'll need to know how to use all three. We're going to start with a while loop. Connecting back to the video that introduces loops, this is going to be a structure in which we check first, then run our loop body, just like in this flowchart from that other video. I've created a basic program that asks the user to answer a trivia question, then uses an if statement to see if they answered the question incorrectly, and it outputs an appropriate message if that's the case. We've declared a constant at the top for the correct answer, a variable for the user's response, and then a basic prompt. The if statement checks to see if the answer is incorrect using the toUpper method to make the comparison case insensitive. I cover that idea in the videos on if statements if you need to review that. Let's go ahead and run this and see how it works. If I enter something that is incorrect, like Versus, which is their second album, I get a message saying that's wrong, and then it thanks me for playing. Notice that I've written this kind of backwards. It checks to see if we're wrong, not if we're right. So it's a little bit different than the way you might think of it. Being correct means that the expression evaluates to false. Let's try that out. I'll go ahead and enter the correct answer, which is 10. So there's not a lot that happens when I get it right. Since that means the Boolean expression evaluates to false, it just skips that block of code and goes on with the rest of the program. In order to run that block of code, the expression has to evaluate to true. Now, there's a reason we're talking about an if statement in a video on loops. A while loop is closely related to an if statement. It needs to check a condition, and if it returns true, it runs the block of code just like this if statement. The difference is that once the block of code is done, instead of just moving on with program execution, a while statement is going to cause it to jump back up and evaluate the Boolean expression again. And if it comes back as true, it's again going to run that block of code. So all we have to do to see how this works is change the word if to the keyword while. Let's try it. I'll get it correct the first time just to see what happens. Same result as before. It just skips that block of code and thanks me for playing because the Boolean expression is going to come back false. Now let's try entering an incorrect response. Okay, so it is outputting the word wrong, but it's doing that over and over and over again. This is an infinite loop. It's a loop that will go on forever because if the user enters an incorrect response, this Boolean expression comes back true, and there's no code inside this loop body to ever make it come back false. This happens sometimes, so the first thing we'll need to do is stop this program from running. The exact way to do that will depend on your IDE, but most of them will have a square stop button somewhere at the top. You probably just haven't noticed it before because your programs have run and finished so quickly that you didn't see it. Clicking on the terminal or output window and pressing Ctrl+C should also stop your program. To describe this situation, we would say that this loop has a control variable called guess, and we're checking against that with each iteration. In order for the loop to stop, that control variable needs to change at some point. To do that, we'll need to let the user enter another answer, so I'm going to copy some code from up above and prompt them to try again. You might notice that we're sort of duplicating our code here by asking for the guess again, and that's true. We'll get to that idea soon, but for now we just want to focus on this while loop. Let's run it again with this change. Again, I'll get it correct the first time and it still works the same way. Now I'll enter an incorrect response. Okay, it's at least prompting me for another guess. I'll get it wrong one more time. And now I'll enter the correct answer. Okay, so this seems to be working as intended. I don't really like that I have the input happening on the next line, so I'm going to change this right line to just right. Not a big deal. I want to point out that there are three components to this loop. First, we initialized a control variable. Next, we evaluated a Boolean expression. And finally, we updated our control variable. I want you to remember those three pieces or three components. I also want to point out that this would be what we would call an indefinite loop. At the time the loop begins iterating, it's not known how many times it will execute. We don't know how many guesses it's going to take the user to get it right. They might have it correct before the loop even starts. In that case, the Boolean expression comes back as false right away, and the loop code doesn't even run once. This is the nature of a while loop, which again uses that check first, then run logic. There could be cases when it doesn't execute at all. If they guess incorrectly, the loop will start iterating and keep going until they succeed, and that could take 2 guesses or 5 guesses, or they might never get it right, which would be sad for them to not know the name of Pearl Jam's debut album. That's what we mean by an indefinite loop. That pretty much wraps up our example of an indefinite loop that checks a condition first, then runs the loop body. Let's take a look at a slight variation that runs the loop body first, then checks. In C#, we do that using a do-while loop. A do-while loop is so similar to a while loop that we'll actually just modify this code to use do-while. Before I do that, I'm going to make a copy of this version and paste it down below, and then I'll comment that out. This is just in case I want to come back and look at that code again in the future. If I have good code, or even if I have bad code that I think might be useful, I hate to just delete it. And I'll also update my code block at the top to reflect this change. Alright, the idea here is that we're going to start running code before we even check the Boolean expression, so I'm going to delete this version of the prompt and move my original prompt inside the body of the loop. And I can delete this read line too. Remember, we're going to run the block first and then check the expression, so I'm just going to cut this complete while statement and replace it with the keyword do, which tells the compiler that we're starting a do-while loop. And then I'll paste that while statement after the curly brace that closes off the loop body. Now, since that while statement is no longer followed by a code block, I do need to terminate it with a semicolon at the end of the line. I'll also move my code comment here to match my changes. And let's take a look at what we have. We start by declaring the constant and the control variable at the top, and then we immediately jump into the loop, which prompts the user and gets their input. Then it compares the control variable to the correct answer and, if necessary, jumps back to the top of the loop body to iterate again. It will keep repeating that until the Boolean expression evaluates to false, and at that point it moves forward with program execution. Let's see if it works. I'll start with my correct answer again, and again it works as expected. With a wrong answer, it repeats the loop and prompts me again, and that will keep going until I enter the correct answer. This version of the program is essentially complete, but let's add one small feature so we can learn a trick with while and do-while loops. At the end of the program, let's tell the user how many guesses it took them to get it right. The number of guesses is a new piece of information, so we're going to need a new variable to store that. And we call this a counter variable because, well, it counts. Because I'll want to access that variable outside of the loop body, we'll want to declare it before the loop starts. That way it's scoped to the method and it won't get thrown out every time the loop starts over. So let's declare an int up here called num_guesses, and since the user won't have taken any guesses at this point, we'll initialize it to 0. And let's go ahead and add a comment here for future reference. Next, we have to decide when this counter variable updates. It's a count of the number of guesses, so when the user types in a new guess, it should increase by 1. So that's right here. Beginners often set this to 1, which is understandable. The variable was 0, but now they took a guess, so it's 1. But what will happen is that every time the loop iterates, Num guesses will just be set to 1, even if the user's taken 15 guesses. What we really want is to add 1 to whatever value it currently holds. So that would be plus equals 1. This way, it gets incremented by 1 with each iteration, which is what we want. And the shorthand to that is plus plus, so I'll use that here because that's what most programmers are going to use. Finally, we'll want to output the value of the counter down here after the loop ends. We don't want to print this until they get it right. Let's try it out. As always, I'll get it correct first. And it correctly tells me I took 1 guess. Although I don't like the wording, so I'll fix that. We'll try getting it wrong once and then getting it right. And that does correctly count 2 guesses. So one more try just to be sure. It looks like that code is working correctly. The idea of a counter variable works exactly the same in a while loop. I would declare the counter prior to the loop, update it inside the loop, and use the result after the loop is finished. Now, we can take that idea of a counter variable and use that to create a definite loop, a loop in which we know how many times we'll need to iterate. We'll start a new program for this so we don't get it mixed up with the Pearl Jam program. I'm starting with the same 3 components for this definite loop. I need to initialize a control variable, check a Boolean expression, and update my control variable. The difference is that our control variable will be a counter and not related to user input. We'll start with a loop that counts to 10. Our control variable will be called counter, and I'm going to initialize that to 0. You might already be thinking, wait, that's a problem, don't we want to start with 1? But we'll talk about counter initialization more in a moment. Next is my while loop with a Boolean expression, and this loop will keep iterating as long as the counter is less than 10. To avoid an infinite loop, I have to update the control variable inside the loop. So let's just move that up here and then just increment counter. All right, let's run it and see how it looks. It's not perfect, but it is pretty close. If we start our counter at 0 and then go while it's less than 10, the loop does iterate exactly 10 times. But when we count to 10, we really would probably start with 1. There are a few different ways to address this, and it probably doesn't matter which one we pick. But I'll just change that initialization to 1 and run it again. Better, but now we're only running the loop 9 times, so the counting stops at 9. Again, there are a couple different ways to adjust this Boolean expression. Some people prefer to just change that 10 to an 11. We might call that the spinal tap solution. And that works. Another way to adjust it is to say that the loop will run while counter is less than or equal to 10, like this. And in this loop, it really is just a matter of preference as far as which one you pick. But either version gives us a loop that will run exactly 10 times, which is why it's a definite loop. We know how many times it's going to run. We aren't stuck using numeric literals. I can also get input from the user. Don't forget that the input will be a string, so I'll use convert.toInt32 to change that to an integer. And I'll update the Boolean expression so that it stops at that input number instead of 10. I've got a mistake because it ended early. Let's see. Oh, I used console read instead of console read line. Try that. Okay, that's better. I think the topic of read versus read line is outside of our scope right now, but we should generally be using read line for our input. Another easy manipulation of this loop is to change how it increments. I'll change this update code to add 2 every time instead of 1, and now run it again. It counts by 2s, or basically just gives me the odd numbers since I started at 1. And obviously I could count by whatever number I wanted. This is just meant to be a basic introduction to how while and do-while loops work. In an upcoming video, we'll see how we can use a condensed syntax as another way to create definite loops. But while and do-while loops are always going to be things that we need to know how to do.